Last November, NASA launched a new mission to Mars to investigate the mystery of how it became the red planet and how it may have looked in the past. Now that mission is about to arrive, and here to join us from NASA's Goddard Space Flight Center in Greenbelt, Maryland, is NASA Goddard Chief Scientist Dr. Jim Garvin. Thank you for joining us.
Thanks for having me.
After nearly a year-long journey, MAVEN is finally arriving at Mars. Tell us about the MAVEN mission entering Mars's atmosphere.
So MAVEN is an orbiting remote sensing mission that will study how Mars' atmosphere, the cold atmosphere of today, interacts with space weather, loses parts of itself to space, and connect that Mars of today to the Mars of the past, when we believe the atmosphere and conditions on Mars were warmer and wetter, more hospitable for life. So MAVEN is a time machine to put the Mars of today into the context of the Mars of the past and ask, how did it evolve? Why is it the way it is today? Why is it the red planet, not the blue planet?
What will MAVEN do as it orbits Mars?
So MAVEN's carrying a rich array of instruments that will allow us to measure for the first time how the atmosphere of Mars interacts with deep space, with the space weather, particles from the sun. It also carries instruments that will actually sample the chemistry of the atmosphere as it's being lost to space and connect that chemistry to the Mars chemistry of the past that we're measuring on the surface of Mars from rovers like Curiosity.
What else is NASA doing to better understand Mars, and what are plans for the future?
So right now, NASA has a rich array of robotic missions exploring the red planet. We're on the surface with 2 rovers, Curiosity and Opportunity. We have orbital constellation measuring Mars from the Mars Reconnaissance Orbiter, Mars Odyssey, and soon MAVEN. And we're planning new missions, a new rover mission that will extend what Curiosity is doing to a new place with new instruments to actually capture pieces of Mars for return to Earth someday. All of these missions ask the question, are there signs of past life recorded in the history of Mars, its atmosphere, its rocks, its ices? Can we tell? Could we ever tell? And to open the Martian frontier to the possibility of humans going there to explore our neighborly, brotherly planet.
How does studying the red planet's evolution help us understand the formation of other planets, including Earth?
Well, Mars is a canonical small rocky planet in our very interesting little solar system. But in the bigger scheme of things, we're discovering dozens, if not hundreds, of planets around nearby stars, exoplanets. These planets, we think, have climates with atmospheres and histories as well. By understanding the difference between Mars and its evolution to its state of today, the cold, dry, red planet, from its Mars of the past, perhaps a wet, bluish planet like Earth, we'll be able to understand these other worlds that we're discovering. And also put our solar system into the bigger context of this universe that's out there beckoning, calling to us.
Sounds good. Where can we learn more?
You can go to NASA's website, www.nasa.gov/MAVEN for the MAVEN mission, which will put MAVEN in context to our bigger journey to Mars.
Great. Thanks so much for joining us.
Thanks for having me.